doing this one, we've got square roots or even roots, and we've got division by 0. So both those are problems. Okay. So what we want to do is we want to take the 2 plus x. Okay. So you take the square root aspect, and that always has to be greater than or equal to 0, right? Okay. So that's going to be x is greater or equal to -2. All right. Then I take the denominator, and the denominator cannot be 0. So 5 minus x cannot be 0. So then x cannot be 5, right? Okay. Now, this is an and. We have to have and here because if I just say one of these objects, then it might, if I just say x is greater than -2, great, that always fits and satisfies the numerator. But a value that's bigger than -2 that would blow up the denominator would be 5, right? So if I just take one of those solution sets, I'm going to satisfy either the numerator or denominator all the time. But somewhere I will violate either the numerator or denominator as well. So we need to make sure that we always incorporate both of those as an and statement, okay? And that's kind of where we get to the issue on where we have to kind of think sometimes. Because if this number was like +7, x is greater than or equal to 7, and x cannot be 5, well, if it's greater than or equal to 7, will it ever be able to be 5? No. So that would be something we have to think about logically and kind of decipher what our answers would be. So again, we start with our number line. We'll find -2 on it. We'll find 5 on it. 5's got to have an open dot. -2 needs to have a closed dot. And we're looking at solutions like that. All right. So putting that interval notation, then we're going to go -2 up to 5, kick out 5, finish at infinity. Okay. I'll show you how that contrasts to maybe, let's say, f of x is equal to the square root of, let's just say, 2x minus 7 and x plus 31. Okay. Again, it's a very similar structure, right? Okay. When I say 2x minus 7 has to be greater than or equal to 0, that's going to give me x to be greater than or equal to 7/2, correct? Okay. Which is 3.5, right? Okay. Down here, I say x plus 31 cannot be 0, so x cannot be -31, right? So we need to come up with the interval in which those two things are satisfied by the and. Okay? Well, if I say that x has to be greater than 3.5 and x cannot be -31, so saying that x is greater than 3.5 automatically do that? It takes care of both of them, doesn't it? Okay? So in this situation, our only interval is 7/2 to infinity, okay? Because in that interval, this number doesn't show up anyways, okay? So if I restrict that interval, or that solution set that interval, -31 does not show up, so I don't need to deal with it, okay? On the quiz on, what was that, Tuesday, some of us were getting, I think it was 9/2 to infinity, and then there were 12 had to be a -12, okay? And we were putting -12 in there. Well, -12 is not in the interval from 4.5 to infinity or 9/2 to infinity, so it didn't need to be in there. All right, so those are the little things, guys, that that I think is more important math than being able to do the arithmetic. Does that make sense? Okay, I think the logic of what we're doing, how we write our answers, why those are our answers, and that kind of stuff, that's a more important aspect of mathematics than maybe being able to add, subtract, multiply, and divide. Okay. We feel comfortable with those, and if I give you a couple of those, maybe in the near future, would be all right. Any questions on anything? If I give you a couple max-min questions in the future, would be all right. 17 on this assignment? Absolutely. This one? Okay, so this was a little bit different because we haven't dealt too much with fourth roots, but a fourth root is just a square root of square root, right? So square roots can't have negatives underneath them, so fourth roots can't either. Okay, so all we have to do here instead of x squared minus 9x has to be greater than or equal to 0. Okay, now this is a non-linear inequality. Okay, so what we're going to have to do is we're going to factor this. We're going to x out. Which means x minus 9. That's greater than or equal to 0, right? Now, anytime that you have a nonlinear inequality, okay, and then they show up, they could be ratios, they could be, in this case, a quadratic. There's all types of nonlinear inequalities. They all get addressed by the same procedure. We draw our number line. Okay, we're going to find these zeros, and this one's kind of a special case. It's almost too simple that we mess it up. Okay, these are two factors, right? Does this factor right here that I underlined say x is 0? Does that make sense? Okay, so a lot of people miss 0 on the number line. We've got to have that, and that one's giving me 9. So we've got to have that. We then come over here, and these are our factors: x minus 9, and then remember our total. So what we're going to do is we'll plug in a number to the left of 0. So I'll plug in negative 1 million because that's negative and that'd be negative, right? Okay. And then my total would be positive. I'll plug in a number between 0 and 9. I'll plug in 1. That'd be positive. When I plug in 1 to x, I get 1 back, right? Okay. 1 minus 9 would be negative, so my total would be negative. And if I go to the right of 9, I'll plug in 1 million. Well, that's going to be positive, positive, positive. Okay? So that's what we were looking for, right? When it says greater than or 0, we're looking for positive values, right? Okay? And we can be equal to 0, so we'll close that in. We'll close that in. Okay? Because if I choose 0 or choose 9, it'll give me 0 underneath the radical. And now positive numbers are those values over there and these values over there. Okay. Remember, this is even though I'm doing this kind of sign chart underneath. If I were to wipe everything away, that is just my number line right there. Correct. Okay. And we evaluate to the left of that number line, left of 0 on that number line, we get positive numbers. We evaluate to the right of 9 on that number line, we get positive values. And anywhere between 0 and 9, we evaluate, we should get negative numbers. So when writing our interval then left to right, first value come across to negative infinity. We get up to 0. We say we can include 0. We can union that then with 9 to positive infinity, include 9. The only thing that I would be cautious of, guys, is let's say that, what if I put this, does this really change any if I write the g of x as 1 over the fourth root of x squared minus 9x? Do I really go through the same procedure? But what am I not, if it's in the denominator there, what is that radical not allowed to be there? It can't be 0. So the only thing that would change is that we have open dots at 0 and 9, right? Okay? Those are little things we got to think about. Do I include the zeros? Do I exclude them? Are they providing division by 0? That kind of stuff. Always got to be kind of on our toes and think about that kind of stuff for all these functions. And as we move on throughout the whole year, that's every new function we come across, we got to think about issues of that are provided because of domain restrictions. Okay, it's a good question. If it was if I was a square root, 6th root, 8th root, you do the exact same thing, be the exact same interval. Okay, so that 4, that index of 4 out there just tells me I can't have a negative underneath there, and we got to make it greater than or equal to 0. Yes.
That 4 was like a 5.
Okay, so if it was a 5, it'd be all real numbers. So what's going on here, guys? If we were to graph these, kind of show you there. So the square root, fourth root, sixth root, all those things. Let's just go with x, and I'll raise it to the 1 over n. Okay, so take my n value. So this is going to, if I can set this slider up right, let's go from 2 to 20. We'll go by increments of 2. All right, so what this allows me to, so you see this is x to the 1/2, right? So that would be square root of x. Make sense, everybody? Okay. When I slide that to a 4, now that's the fourth root, correct? Okay. You see how those two are pretty similar looking? Okay. So it just kind of gets, this one's kind of a more gradual kind of increase, and that one kind of, goes up fast and then kind of slows down. And that's going to just be magnified even more as I keep going up into the larger roots. Does that make sense, everybody? Okay. So anything that's of an even root is going to kind of have the same behavior. If I go an odd root, so let's start this thing at 1. Okay, so obviously there's x, y equals x or whatever. If I go 3, there's cube root, right? Fifth root, seventh root, ninth root. You see similar behaviors, right, between all these odd ones. And they kind of, they even kind of look like the cube, or the square root over here, right? But because it's an odd root, we can take the negatives as well. You take the cube root or the fifth root of negative numbers. That's how we get these portions of the graph. So that's all real numbers. So yes, your question was, what happens when, let's say, what would we have under there? X, was it x squared plus 9x minus 9x? So let's put that function in. Okay, so we were interested in when this thing was taking the fourth root. Okay, so there's the square root of it. So if I square root that, which would be the fourth root, looks like that, right? And if I square root that, well, I guess not square root it, but take the sixth root, you keep seeing the kind of the same behavior, right? Okay. Now, if it's an odd one, an odd root, we should, obviously there's the parabola if it's the first divided by the first, but when I go to the cube root, okay, kind of similar, but now we get that kind of gap that had that the square root had and the cube, or the fourth root had. We get that gap kind of filled in down there in the bottom. So now nothing really gets kicked out, as we see it, those odd roots continue to change. Is that all right? Does that help visualize things? And that's something to think about, guys, all the time. If we're debating or we can't look at it algebraically and make a decision, absolutely grab your graph and see what connections you can make that way. It's a good question. Any others you guys want to talk about? All right, so with this one, guys, they're giving you two functions, okay? And I like color coding things, and I don't know why they don't do this. They color code the graphs, but then they don't color code the letters. So then I have to always go back and think, okay, which one was blue, which one was red, that kind of thing. But they're asking us, which is larger, f of 0 or g of 0? So f of 0, okay, that is saying when you go to the red curve, that's an x value, right? 0 is an x value, okay? They say when you go to the red curve, with x being 0, okay, what's your y value? It's 3, right? So f of 0 is 3. And then they say, okay, find g of 0. Well, g of 0 would be about right there, correct? It's about 1/2, correct? I kind of guesstimate, but the question was then, which one of these is greater? 3's got to be greater, right? Okay. And then we'll scroll back down to another one, which is larger, f of 3 or g of 3. So again, now, f of 3 or g of 3. Okay, so f of 3 says go out to the x-axis of 3. Now go find the f curve, which is the red one, and see what your y value is. So that's 1. And then it says go out to g of 3, find your blue curve, which is going to be a y value of 4, and this one is greater, right? All right, so what they're doing here, guys, is these are inequalities, right? Okay, they're asking you which one, graphically trying to get you to realize that if I had these two graphs on a graph in front of me, and I'm asking questions about where is the green, or sorry, where is the blue one greater than the red one, or where is the red one greater than the blue one? If we can understand how the y values are relating to one another, that's how we make that decision. So I think they start asking you that here. For which values of x is f of x equal to g of x? Okay, so f of x, remember, f of x is a y value for the red curve. G of x is a y value for the blue curve, right? They're asking where are the y values equal? Well, doesn't it have to be right there and right there? So they're asking for, okay, those are where the y values are the same. They're now asking what are the x values that go with those. Well, the x value that makes those the same would be -2 and +2. They want to know when is f of x less than or equal to g of x. So these are kind of staggered questions. When is f of x less than or equal to g of x? Okay. Well, if I already know where they're equal, okay, everywhere else they're unequal. Does that make sense to everybody? Okay. So I'm going to just color this stuff in these intervals. Okay. So in that interval, they're unequal. In that interval, they're unequal. And then in this yellow interval, they're unequal. Does that kind of make sense to everybody? Okay. So now in the blue one, okay, the blue interval over here, G is greater than or equal to F, right? Would you guys agree with that? These values here are greater than these. So I'll just write over here, G is greater than, let's go write greater than, because equal to is at that intersection. So let's just say G is greater than F, okay, in this blue. Would you guys agree the same thing happens over here in the yellow? G is greater than F. And then here in the green, F, or sorry, let's just start with G again. G is now less than F. So if we can do that graphically, then we should be able to answer any of the questions. When is f of x less than or equal to g of x? Well, when is f of x the smallest one? It's in the blue interval and the yellow interval, right? So from -infinity up to -2, and then from 2 to positive infinity, we would have that inequality. Sammy?
I don't know what you're saying.
Oh, I'm sorry. You're right. I'm sorry. I overlooked that. So, because that's a closed dot, right? Okay. I was viewing it as an error. You're right. So I should include infinity. So this should go from, f of x is less than g from, was it -4 to -2? So that interval. So I guess my coloring kind of messed me up. So those intervals and those intervals, right? It's a good question. My fault. Does that help with those? Okay. And that thing, guys, I think some of you are experiencing this, and it's great. It's really good. Even though it's a struggle, it's good that you're experiencing it and that you're being able to target and understand it. But I think your struggles are coming because of the notation. They're trying, and I think showing these questions with this notation is getting you to view and understand that if I don't understand the notation, I'm going to struggle in addressing the question they're asking, right? So that, I think, is something to keep in mind as you move through this class and every other class you ever take mathematically or science-wise. I think in physics, you guys do anything with forces in physics yet? Nothing with forces? When you get to doing some stuff in physics and you start talking about forces especially, you guys have done vectors, right? Okay? So you're on your way to dealing with forces then. There's going to be a lot of notation, a lot of variables that have subscripts and superscripts and stuff like that. If you can keep straight the notation, it makes the processes a whole lot easier, okay? But if you lose sight of the notation, you're going to struggle, okay? Well, I was taking some graduate classes the last couple of years so I can teach this course, and they're math classes that I'll never, ever teach the content in those math classes to a high school class. And there, I would spend, we'd have like assignments over the course of 2 weeks or whatever. I would seriously spend 8 to 10 hours, guys, in 1 week just trying to learn the notation, okay? Because then once I learned the notation and understood how things were being written and described using that notation, the math came pretty simple, all right? But if you don't understand what the math community is trying to tell you with their notation, you're up a creek, okay? Trying to think about English class. If I don't know what commas are, parentheses, quotations, exclamation points, question marks, I don't know how to read that stuff. I don't know how to use it in my writing. I'm probably not a good reader. I probably can't comprehend very well, and I probably suck even worse at writing, okay? So it's the same thing mathematically, okay? It's the grammar of math that we have to kind of understand, okay? So hopefully we pick up on that and keep asking those types of questions, guys, because I don't want you to be stuck at some point saying, I got this question wrong. I understand the concept, but I got it wrong because I don't know how they're phrasing things.